Good afternoon, good morning, ladies and gentlemen. Welcome to this TDL seminar on AI and software automation. Got a really good panel. We're going to go for an hour and then finish in an hour's time exactly. Questions are possible through the Q&A chat down at the bottom of your screen. This session is going to be recorded, and the recording will be made available in a few days' time, as well as a summary report, which will be on our Substack account, which you're very welcome to access and to circulate as you see fit. So without further ado, I'd like to hand over to our moderator, Claire Vizsik, who is a TDL strategic advisor, who will take us through the introducing the panel and the panel discussion. So over to you, Claire.
Thank you very much for hosting us, and thank you very much to our distinguished panelists for joining this panel and for sharing your thoughts in the next hour. Software assurance certainly is not a novel topic. It has been front and center of a lot of discussions in software development, software maintenance, software integration of legacy and new software programs, new paradigms for software development, certification programs, associated standards, and a lot more. Artificial intelligence has entered this space outside of research relatively recently. There was some level of resistance in the community to introducing some level of automated analysis because of a variety of issues that maybe we will be able to in part address today. But more recent work indicates that there are a lot of capabilities that artificial intelligence can support to the extent it is possible. There is the merge potential for the paradigms that artificial intelligence can support as well. For instance, introducing practices that are used in firmware and hardware assurance to software assurance. All of this we will try to address today to the extent possible. I would like to welcome our distinguished speakers in alphabetical order. We have today Adam Hastings, who just joined the Department of Computer and Information Science at Fordham University. We have Ian Oliver, who is a professor of practice at Oulu University. We have Ari Singer, who is co-founder and chief technology officer of Trustify. And finally, we have Fiona Stewart, security assurance specialist at Trust CB. I cannot resist saying that Fiona was in charge of leading the development of the current version of common criteria in SC 2027 in ISO JTC1. So with that introduction, let us start with each of the participants talking about their views on the topic. What do you think is the state of software assurance? How do you think AI can contribute to its development? What do you think are the lessons learned? And generally, what do you think is important in this field? Adam, would you like to start, please?
Yeah, I'd be happy to. So thank you, Claire, for the introduction. Like she mentioned, I'm a new faculty member at Fordham University. I recently finished, I was up at Columbia just before that. So my area of research is kind of a mix of a few things, but kind of one of the primary lenses that I use to analyze security problems is out of economics. So I'm interested, and I've been using kind of the view of like, what are the costs of security? Who pays the costs? Are there asymmetries in the costs? And so I view I would say the rise of these like generative AI tools as a great opportunity to re-examine maybe what we thought were like stable points in this like game between attackers and defenders. So like this obviously people are interested in using these tools to automate assurance processes. Also on the other side, there's going to be attackers using these tools to de or automate the exploitation of these automation systems. And so I hesitate to say that I know where the future is headed, but at the very least, it's a really interesting moment in security, because we're going to see kind of like what we thought were stable equilibriums get shaken up. And I guess I'll say more about that later, but I'm happy to I'll stop for now.
Mhm. So, do you think there are immediate benefits of introducing artificial intelligence as a method of analysis with regard to the economics of software development? Or do you think the economic benefits will be somewhat delayed?
Um, I'll need to think about that for a second.
Okay.
Yeah, it'll come back to me on that.
Okay, that's I will come back to you
Okay.
with this question. Ian, what do you think uh, of the state of this field and its potential?
Okay, at the moment, I just think we're extremely naive about it. I'm going to come at this from two directions. One is I've got a background in formal methods, and we did a lot of formal analysis of systems that actually ended up in automobile devices, etc. The 3GPP protocols. The complexity of those systems now has not got so great. Those methods are now struggling, even though, for example, there was wonderful work done at Intel back in the 90s, extending state space out massively. Um, I I think if you are going to bring AI into this, then we really need to consider what the hype is in there. However, in saying that, I'm also going to come from a sort of philosophical position, and actually start asking, okay, so what are we actually trying to do with these? What are we trusting them with? If we're using AI to test our software to come up with compliance, does it need to be compliant and trusted in the first place? And then how far back do we go with that? Where is the point that we start uh, working with our root of trust for AI? Where's our point of belief starting, etc.? And ultimately, this just comes down to how much risk are we willing to take, and how much risk are we trying to give or pawn off to the AI to take for us, which leads to another philosophical question: is does AI take risks? But I want to come back to Adam Hastings' point. You touched on game theory a little bit, talking about attackers and defenders. Um, they're the same people. They just have different value propositions, or maybe different value. I wouldn't even say they have different business models. They have the same business model. They just make their money in slightly different ways, and that's another thing to consider within this. But I would say at the moment, the way we're trying to use AI is the same way as the way the formal methods community were behaving in the 1990s, and it was great hype and great things were happening, and then we hit a brick wall with the tooling, with what it was capable of doing, and so on. So I think we're riding a little bit of a hype cycle at the moment. A little bit, I should say, a massive hype cycle. But let's see where it takes us.
Um, Excellent points. It's impossible to deny that we are at the height of the hype cycle with regard to artificial intelligence. You said something that resonated with me, although I would have difficulty to define it. You talked about the root of trust for AI. What do you think it is? How do you define it? How can we
Oh,
find it?
I don't know. I mean, I think we're going to have to. Maybe we need to approach this from a very, very philosophical position. Um, I mean, really epistemic logics, deontic logics, are we obliged to trust AI? And if we're obliged to trust AI, aren't we obliged because we know that we don't have the knowledge to fully trust it? I don't know. I don't know. It's obviously not as simple as just sticking a TPM into a computer and then running an LLM on top. That's another discussion. But I don't know. And I think we desperately need that philosophical discussion.
And do you think, as a continuation to this question, do you think that using AI as the ultimate analyzer of assurance, do you think it will have the potential to actually amplify rather than mitigate the risks under certain conditions?
I think we have the risk of it enhancing the risks, certainly. But I think the point where we want to take AI, it almost becomes very symbolic in its operation, meaning very strict, very mathematical, very formal, which seems to be the antithesis of what we're being told AI actually is. So, yeah, maybe we need to have a discussion what this word intelligence with. I actually like to call it augmented ignorance. But I'm not sure whether that's ignorance on the point of the software that's running the AI or ignorance on the part of the humans who almost believe it without questioning it. And I think that's where our danger lies.
Absolutely. Even on the consumer side, there is a rise in applications that test whether or not humans took AI output uncritically or actually read and analyzed it themselves. It certainly is much more needed for fundamental infrastructure topics like software.
Yeah.
Thank you, Ian. Ari, what do you think?
Yeah, thanks. So I'm coming at this from a security practitioner perspective, a security architect, not always specifically focused on software. So, but actually, Ian, I also keyed on, well, I keyed on one thing that Ian said also, which is this concept of root of trust for AI. And I think in preparation for this discussion, you know, one of the things that I focused on a lot was, okay, what can you trust? You know, who's trusting who, and you know, what does it mean to use AI? And so just a couple of, you know, off the top thoughts. First of all, I would say that whatever answer we give today is unlikely to be the answer in 6 months or a year. At least right now, you know, we've observed really dramatic changes both in the availability and the capabilities of AI, and also a proliferation of different AIs. So you know, now you're in a situation where you can come up with a question and go 5 different places or 10 different places and get different answers, and then try to match those up. So I think it's evolving, which from a security perspective is a bad thing, right? Like, you know, in the early days, you would say, well, crypto can't be trusted unless it's been around for 20 years. And now we're talking about AIs that have been around for a few months, and putting all your trust in that is certainly, there could be some risk there for sure. In terms of how it applies to software assurance, I would try to look at it from the perspective of, well, what is AI good at? What's it not so good at, right? I think it's very good at high volumes of processing in a short period of time. It's really good at attention to detail. So if you want to check, you know, 100 conditions, it can do that very quickly. And for publicly available information that is not in dispute, it's very good at, you know, looking at that and bringing it up. I would say what AI, at least today, tends not to be very good at is understanding imprecise rules. So if you tell it sort of generally what you want it to do, you're going to get very, you know, varied results. And it also tends not to be great at strategizing, you know, inventing new ideas. So, yeah, I guess that's sort of the starting point, you know, where I'd come at this question.
We have always talked about the difficulty of even creating adequate security models for complex systems with different components, where each of them has established and maybe viable or relatively viable security models, but the complex system combining and aggregating all these components doesn't really have an adequate way to treat all the security issues caused by integration, especially with regard to assurance. Do you think AI can help with problems like that, or is it too complicated?
Well, yeah, I mean, I think complexity is also a really key issue because, you know, I mean, I use AI in my everyday work, and one thing I have to often do is say, bring down the volume, bring down the complexity. Let's focus on one thing at a time, right? So I think AI has the potential to very rapidly increase the complexity, which again is counter to high security. But I think if you're using AI specifically with the goal to reduce complexity, say, all right, I would like to use the AI to figure out how to squeeze out all of the extra variables and simplify things. I think there is a lot of potential for AI to simplify. And then, you know, and the question of, you know, is AI, you know, going to be the arbiter? Is a human being the arbiter? I think the ideal would be if AI can streamline and simplify things in a way that a human can understand, then the human can vet the AI and vice versa.
It's impossible to disagree with this. We will need certainly to see how the situation developed and maybe revisit this question in a couple of years to see what was helpful, what was detrimental. But theoretically, I agree completely. Fiona, you spent much of your career actually addressing complexity and creating rules that go across different paradigms. So what do you think about assurance and its relation to artificial intelligence?
Yeah, that's a really good question. So, yes, I've dealt in my career with everything from mainframes down to the tiniest chips and online applications and mobile devices and everything like that in between. So, and in that, looking particularly at the topic of security assurance. So, how is AI perhaps changing things? So, as the other panelists have mentioned, it's somewhat new. Certainly in its popular instance at the moment, we're seeing, yes, definitely a great lot of attention given to it right now. And we're not alone. We've been thinking about that and how this tool, and I'm going to call it a tool, that we could potentially use in helping us give us confidence in the security aspects of things we're developing and the technology we're developing. The large language models, the LLMs, that I've seen so far are pretty good as a whole, finding things where we already have many examples or a lot of information for a topic. So this is how they're trained, of course. And so this is where their strength is. Perhaps where the weakness would be the corollary of that, when we're looking for things that are not well known, that we don't have many examples of, this is where the tool will perhaps be a little less useful or reliable to us. And particularly, well, I'm going to say particularly for the security assurance aspect, well, I'm not sure this is true, for that it's only for security assurance. But for example, if you're training an LLM on, let's say, GitHub, or even your past code base within an organization, you're also teaching the AI all the mistakes that have been made in the past. And that one can be a little bit difficult to navigate, especially when we come to security assurance and security items. What we really don't want to do is incorporate all the mistakes we've made before. So that's an interesting view there. What else can I say? So that means, yeah, we're going to rely heavily on the quality of the training data that we've put in. I found it more useful so far, and it's a young tool. Yeah, we can find coding and programming mistakes, especially the more common ones. More problematic, perhaps, the model or design errors. They're a bit more complex. Maybe it gives some clues. Maybe not. I think we still today need a human an experienced human to look at that. And I'm finding there's particular places where it might work better than others. So, for example, different protocols, cryptographic protocols, it's pretty good at. It's got a known model to work from, and I think we get a little bit better results there.
Could you expand on what you mean by that, actually, specifically with cryptography?
So when we have a cryptographic protocol that might be standardized, is standardized hopefully. This is something that AI is good at. We're finding it works less well on things like software APIs, where we have a really well-defined standard that it can ingest and think about. Then that's where we're finding pretty good results in terms of its analysis.
So just to make sure I understand, we're saying we have some standard for a cryptographic algorithm, and we're asking an AI tool to verify that some implementation meets the standard, and that's working well.
Yeah, that's one example, and also into communication protocols is an area where we get good results.
Yeah, I
So
mean,
if you look at test automation, right, cryptographic test with regard to the faithfulness of an implementation to the standard has been implemented some years ago, and actually is actively employed in a variety of areas. This has not been possible in, for instance, hardware because the platforms are so difficult, because the platforms are so different from one another. It has been impossible to fully automate the tests for evaluation of the compliance to standard of various implementations. It just requires too much effort to formalize the different features available on different platforms. I think that's what Fiona meant. That probably
Yes,
would be
thank you.
true. Yeah.
Yeah,
Oh.
it could only we were only verifying up to modules of a certain complexity, is my understanding. Is that a current understanding?
Well, probably also certain variability with regard to a cryptographic protocol or a cryptographic algorithm implementation. You have to implement it as is to be compliant, right? With regard to security features in platforms as different as servers and TPMs or some small IoT devices, right? There will be a lot of different features and implementations that need to be reflected in order to automate. So I think in this case, we sort of connect automation and artificial intelligence to some extent. I think Ari has a lot to say on this, right?
I was going to say something, but Ian, and I will, but Ian was being very polite with his hand up. So why doesn't he go?
Yeah.
Yeah.
Fiona
Go
made a
ahead,
very
please.
thanks. Fiona made an interesting point that it seems to be working in a sweet spot between very, very highly formally specified systems, as you see with hardware, and
Right.
very loosely specified systems, which are, I mean, that's vibe architected systems where you just say, okay, look,
Exactly.
we've got these components. So there seems to be then a very nice sweet spot in the middle. It's those systems that are formal enough to analyze, but we've never gone down or needed to go down the full formal analysis route. We don't see people writing in Z and using theorem provers. So there's a sweet spot there. The question I would then have is why is that happening? Why are we not? You'd have thought that AI would have been very natural and worked very well against these very highly specified systems. But is it that the fact that they are highly specified means that the AI can't work with it? It doesn't suit that kind of those kinds of algorithms. But on the other hand, I mean, if we can throw, for example, IETF specifications, 3GPP specifications at AI and get some results out of it, that's a massive potential reduction in workload. So I'm kind of curious now about this middle ground. That's a little bit of a surprise, or it should be considered a surprise, I suppose.
It might be volume. I suspect, I don't know, that when you come to the formal languages, they are less examples about to train the model on. If you're talking about commonly used protocols of one kind or another, there may be a great many implementations it can learn from. I don't know. I'm just guessing.
Or maybe it's just the sheer volume of specifications that we have that have been written by very, I'll say, very clever people. Myself, no, but we've got a large volume of these specifications. I mean, if you look at, for example, the output of GSMA, 3GPP, and all the telco stuff, there's a massive amount of material there, and it's of good quality.
Yes. Yeah, I mean, so I mean, one of the things that this made me think about is well, Fiona was talking about the quality of the training data, and in the case of cryptography, for instance, it's either right or wrong, and it's perfectly verifiable, and there are a lot of ways to check it. So I think, if you're looking at when AI produces a result for you, right, and and I started playing around with it a couple of years ago, right, and the hallucinations were obvious and immediate. They're much less obvious and less immediate, and in many ways more dangerous now because it's become much more convincing. But if you want to look at where the strengths of AI are, it's where it's really unlikely to make a mistake because things are specified so clearly and it's so checkable, right? You know, I mean, as someone who has not done the programming myself, but been around lots of programmers who you know program with crypto protocols and that kind of thing, it's really you know, you get one little tiny thing wrong and everything is completely wrong, and it doesn't tell you what's wrong, right? So you know, I think having AI have the ability to do so much checking all at once and get this really easy yes no answer, I think that is an area where it can probably be very helpful.
I agree. And another distinguishing feature, as you so correctly pointed out, as did Fiona and Ian, in cryptographic algorithms, implementations, and related protocols, it's either right or wrong. Whereas implementing a security feature in a certain way in software, depending on where the software is located, what it is used for, what API it is using, and so on, could be right in one situation and wrong in another, depending on the variety of parameters. So that might be the distinguishing feature that makes it more difficult to use AI effectively in all situations, at least at this point. So maybe this is a good time to return to the economic foundation of all this. What are your thoughts?
So I actually wanted to respond to something I think Ari said earlier because I had a chance to think about it. So he mentioned this this thing about, you know, AI can increase complexity or reduce complexity, and hopefully, you know, we use it to reduce complexity because, you know, reduce complexity is easier to reason about, easier to prove secure. If we look at the incentives of, I guess, what we could say like the VC ecosystem, the MO isn't go fix your technical debt. It's move fast and break things, right? There's incentive to just build. And AI tools make this incredibly easy. We have people with you know, very little technical ability that are I guess presumably making things that are you know, profitable. And so like first of all, I think we need to just be aware that there's as much as we'd like to reduce complexity, we're going to live in a world where I think it's very much the opposite. And I don't have maybe a nice conclusion, but I think the thing to be aware of is that I think the demand for software assurance, you know, after some horrible vibe coded monstrosity has been created, I think there's going to be a huge increase in demand for kind of verifying, you know, even just to end users. Like if I use this, I don't know, Uber for dog walking thing that someone made in 20 minutes, is my credit card information going to get stolen? I think maybe it'll get to the point. I mean, I hope not, but conceivably it could get to the point where even end users are asking for this stuff because they're just aware of like this new class of risks. I don't know. So, you know, proving to not just yourself, but maybe even others that this, maybe it's a standards thing. I don't know. But I just think there will be more demand for this type of stuff in the future.
It's impossible to disagree with this. When so much becomes automated, additional risks and attack surfaces are inevitably created even by experienced programmers that understand the foundations of security. Now that it's much easier to create almost anything and make it work.
Yeah.
It's a different situation. Go ahead.
Yeah, I want to respond to Adams because I think this idea that we've had for years, it's, you know, we construct stuff fast, we build fast, we break things, and it doesn't matter. Yeah, it really does matter that we break things. You know, as much as we like to say, hey, let's be agile, we're all in very strong processes, and we're not allowed to break things because that doesn't make us money. So I think that's a horrible fallacy or a lie that we're being told. But if we are in a situation where people are using things like Vibe to code software that should be secure, credit card processing or anything that interacts with this, I'm waiting for the first Vibe coded medical device, and then I'm quitting this planet. Are we going to see a situation that we're going to have, if you're going to do that, then it needs to be assured by multiple AIs, and we're going to use those AIs just as a matter of course in the same way as that we use, I don't know, syntax highlighting in editors these days to remove bugs, etc. There is a business there. But I think where this takes us now is if you've got very inexperienced people who believe they can build complex software just by giving a few keywords to Vibe, they're not going to get past all this assurance. And it's in some ways it's going to take them out of the market again, as people who suddenly believe that programming was easy actually turns out no, it's incredibly complex to get things right. So I see this move fast, break things idea as it's not going to happen as soon as you start adding on these AIs or this additional checking that we will require for assurance in any form. It's probably even going to return to the fact that we still need the experts there who have this interesting mental view of the world. I mean, programmers, architects, etc. We have this very interesting view of the world, and we probably ruined it. Who know how to navigate and really understand what compliance actually means and how you build these systems. Yeah, but that was just my take on sort of this economic idea that's going to come up, that it's all going to be easy and magic. I think it's going to require even more experts to navigate this.
Yeah, I
Probably,
think I would agree.
or it might also break the foundational models that enabled a lot of thinking in the internet economics. For instance, Akerlof's model about the market for lemons, right? Here we are in a situation where there are a lot of automated functions where the users have no experience of them at all, although they are all potentially experienced goods, and they're still using them.
Mhm.
Yeah,
Because some of them have, yeah, go ahead.
I think the market for lemons is an interesting, because it tends to get applied to a lot of social media companies, that we are being sold lemons by, I won't mention any companies, and that model there. I think, to use the car analogy, which is what the lemons was based on, I don't think
Yeah.
we will end up in a situation where, or it will not be tolerated that people keep on producing lemons. We cannot tolerate bad software, because it's not going to break things in the sense that, hey, here's a nice new product and we can innovate over it. It's going to break things completely. Let's build a Vibe coded medical device. That's going to sound so great on the front page of some, I don't know, CEO Weekly. When it starts killing a lot of people, and which it will do very, very rapidly, we're going to see this rebound. So there is no market for lemons in systems that require the level of certification insurance that we are talking about. It cannot be accepted, or if it is, it won't be accepted for very, very long.
It
I
is
mean,
true for some autonomous systems. It's probably not true for a number of software widgets that are being circulated and actually create a lot of economic power. Go ahead, Adam.
I'm just thinking about something said earlier, move fast and break things. The joke I like to make is that I view it not as a logical conjunction, but as a logical implication. Move fast and you will break things. I lost my train of thought after that. Sorry.
I was
Yeah.
I was gonna jump in and say I mean I think Fiona characterized AI really well as a tool. And I think at least today that's really how it needs to be treated, right? I mean, at some point, who knows what AI is going to be able to do, but I think I mean, the vibe coding medical device, I definitely, is a concern, but that's because people are using the tool the wrong way if they're doing that,
Mm.
right? So,
Might be.
when you talk to a software architect, they'll tell you AI takes them in all kinds of wrong directions, and it can't do that, the software architecture that a software architect human can do today. But it can help with other things. It can help track down little issues and find, inconsistencies and,
Mm.
resolve your syntax
Yeah.
issues instantly. I mean, I've taken big chunks of code and just pasted it in and said, hey, what's wrong with this? And they'll say, oh, this little thing. And then it's fixed,
Mhm.
right? So I
Yeah.
think it's a tool that is evolving very rapidly. So it's really hard to know how to use it today or in 6 months, but it has to be treated as a tool, and you need smart people to figure out how to use it correctly.
Yeah. And
Excellent point.
not
Go
just how
ahead,
to
Joanna,
use it.
please.
Sorry, not just how
Go
to
ahead,
use
please.
it correctly. Am I on mute? No. Now I've lost my thought. But to use it in the right way. So, for example, today, yes, as you just said, AI can be very good at helping with simpler things. So, with syntax, with common mistakes, and so on. It may be very good at removing those mistakes. But from the assurance perspective, what I'm looking for is not that it did, but I need to know exactly, I need a clear set of what was fixed. We can improve security, but if we have an unclear subset of things that are taken care of, we've still got to go in and look at those. One interesting thing that we miss, I'm not sure if this is good or bad, but for a long time, as we went through various evaluation or certification testing projects, and we're looking at source code, yes, we already had tools that might check various things, but we're putting our human eyes on and reviewing that code as well as applying the tools. And in many cases, we had people doing that would be able to recognize who wrote that code from their particular mannerisms, the way in which they write code, perhaps the style of their comments, even, the kind of mistakes they make, or how they even perhaps format it, or techniques they use. When people are now using AI to generate that code, we are losing that insight, and we're losing a subjective view of the code that we're looking at. What is its quality? Is it good quality? Is it a load of rubbish? Is it low quality code? When people are using AI to generate that code, we lose that viewpoint.
Excellent comment. And developing this thought, we talked a lot today about how AI, that is still a tool, not a completely new paradigm, a tool that can save a lot of time, but also can lead to additional errors and misconceptions. How this tool is overused in a number of areas associated with assurance. Can we talk briefly about the areas where this tool is underused? One that comes to mind where Fiona can comment on, and the rest of the panel as well, is the development of standards. That is completely manual at this time, but probably could be in part automated. What do you think? Do you think it can be automated to some extent?
I actually work in standards, and the biggest
Right.
issue probably with standards is patenting. And because we
Yes.
need patents,
Mhm.
and AI is not allowed to write patents. So there are very strict rules regarding the use of AI in patents. This is probably for the best, I think.
You think?
But
Okay.
that's one thing that comes up there. So
Is that I assume an EU rule, or is that in the US? Where does that rule apply?
at least I would say in the EU. I'm not sure how it's going to apply in the US. I think this is going to be long developing anyway.
Right.
Yeah, I mean, we can
Um,
use AI to generate the standards, but then there is the question of if there is intellectual property, or who wrote the intellectual property, who
Right.
owns it. So there's that aspect, which is something you don't get when you use AI to check the standards or check, the assurance of the code, or whatever assurances you require of that standard.
Yeah, I am not suggesting that we should generate standards, although at some point it may be possible. I
Well,
don't see this anywhere on the horizon yet. A lot of time when developing standards goes into actually non-standard work, all kinds of summaries, formats, references, and things of this nature that probably could be automated for human editing. So I'm talking about sort of, additional work that have been instituted many years ago to form the standards into a unique system where they have the same format, the same parts of the document, and so on. I'm also talking about, several years ago, we evaluated some long standard documents for consistency with artificial intelligence, and we found some inconsistent statements that the humans didn't catch, probably because they were not of paramount importance for implementations. So these two areas, evaluating the consistency, helping create the core document without the main concept included, yet probably would be helpful.
Now, this I fully agree with. Using it, because we have in telco so many standards split across a number of groups, and especially when you start going to other verticals, then being able to have AI compliance checking between these and different areas that you might not be familiar with, this is a perfect use case. And also, when you do write a standard, or when you start getting that, having that automation around that to check for consistency, and also to give hints, but not to write. Especially when it comes to assurance, if you need to have certain kinds of assurance for EAL levels, if you like, when you're writing a standard, or what would you require to move into that area, this is where it's going to be absolutely invaluable.
Yeah, I think it will be able to speed up the process to some extent if it's possible to implement it. But Fiona, who ran a huge project, probably knows better. Do you think some of standard writing could be automated and consistency could be checked automatically? Or do you think we are not ready for that, Fiona?
I would just
It
say,
depends.
go ahead.
Sorry.
Yeah.
Go ahead.
I was just gonna say, I think you could use AI to draft it and then have the human finish writing it or check it. I mean, the point is, I think, AI can help with the ideas, can help with the editing, but you want the human to actually be the one to finalize it.
Oh,
Absolutely.
It depends on the standard, and also I'm trying to think how this would apply. Most of the standard organizations are working on a consensus system, and that, I think it would be a shame if we lost that. Politically, very often on an international basis, even World Trade Organization, you know, we're looking for that input and review and acceptance from organizations or nations around the world. I don't know where else nations would be. I don't know how AI can replicate that kind of consensus. You can write the words, maybe, but
if AI could help pre-write non-significant parts but required parts and suggest the references, I don't think that would affect the consensus system, because the consensus system applies predominantly to the core of the standard.
yeah.
And also it could be edited by humans, even if it was created faster by AI.
Well, would it? I mean, I'm thinking now of the ISO process. Actually drafting the words, the body is often maybe the quickest part. The slowest part in a 4 or 5 year cycle is going around, getting those reviews, getting each stage and comments back on how this could be improved and so on. So a lot of that timing is based on how long it takes people to review and comment, realistically. So yes, AI might be able to draft some words at the beginning or even input comments and make changes, but you still got to allow that review process, you know, maybe a 6-month cycle or however many month cycle that standards organization is on.
That is very true. There are sort of two processes, you know. One, a few people are writing the core standard before the comments. This is time consuming. This could be improved with some level of automation. Then the comment and review part of the process. I don't know what role, if any, AI can play in this. Very good point. We are close. They might be, but this is probably a subject of another long discussion.
Yes. So, you've got me thinking.
The very last question of this panel. Everyone said that AI as a tool, is a productivity improvement support. Still, for software assurance, a more general process of security assurance requires the presence of experienced humans. Looking forward in the future, can you tell me what is the role of human as AI's input into the analysis and production of the components of assurance improves and becomes more solid? And let's go in the alphabetical order again for this. So,
can we do reverse alphabetical this time?
A reverse alphabetical. Okay, so we'll come to you and go alphabetical. Ian, what do you think?
Yeah, that's not quite reverse alphabetical, but yeah. Human in the loop, yes. The one thing that now worries me is how do we get the experienced people? If AI starts replacing a lot of that work, where are the experienced people coming from? How
That's
do
a
we
great
get that
observation.
experience?
Yep. You've stolen my thought, but that was exactly it. If we need more senior, experienced, skilled people to do the harder stuff, to review if AI is doing a good job or not, somehow they have to get that experience, develop those skills, and learn how to apply it. And if that AI is doing that, I'm going to call it junior work, how do we do it? Or do we have a loss of brain, human brain power, and being able to develop skills? I think this is a concern.
I'm going to give a quick analogy. So I'm teaching my son the fundamentals of software architecture at the moment. And I've actually noticed that to explain a lot of these, you have to understand the fundamentals of compilers, etc., and right down even down to CPUs and
Yeah.
instruction sets.
Yeah.
He's never going to program a Z80 CPU in assembly language. But having that skill on knowing how that works
Yeah.
actually underpins pretty much everything that he is ever going to do,
Yes.
regardless of not whether it's vibe
Yeah.
coded or not.
Two
Yeah.
comments on this. One, in every panel we have, people comment on the erosion of expertise because of artificial intelligence in a variety of ways. I think we all agree that this is definitely happening. The second is we may underestimate the ability of programmed artificial intelligence models to do a lot of things. For instance, DeepMind actually performed this summer at the gold medal level for the International Math Olympiad. Having attempted to participate in this, I know how difficult that is, but they were able to solve 5 of 6 problems at the level that a human could. So that is incredibly impressive. So we need to preserve and develop human expertise. At the same time, we need to also understand how potentially beyond our understanding this system that is a statistical simulation of our mind has developed. So in the last couple of minutes, let's ask the rest of the panel. Ari, what do you think about the need for the human in the loop for the future of this field?
Well, I think human in the loop today is definitely needed. There's no question that AI isn't there yet. I think with respect to expertise, I tend to be optimistic, that people will figure out what people are needed for and what they're not needed for. The example people always use is the word processor that people won't be able to spell anymore. I kind of worry today with kids that they don't know how to spell, but I mean that didn't ultimately prove totally true, right? There are lots of people who spell very well right now. And so I think there will be lots of people who understand security, who understand architectures, and maybe AI will help humans understand these things. But I don't know. So I mean, today the expertise is definitely needed. Tomorrow, it'll be really interesting. I don't know the answer.
Fiona, any final comments?
I'll
Yeah.
Go ahead.
Go. Yeah. I will
I'll
come
say,
to you.
I'll say I'll take a I don't want to say dissenting point of view, but I'm just thinking about this data from Waymo, and they're claiming that they're far safer than human drivers, and I'm not maybe like what if we're constraining ourselves by thinking we need humans in the loop? Like if we have human drivers that are worse than robot drivers, do we want humans in like the self-driving loop? I don't know. I'm not trying to make too strong of any claims here. It's just something to think about, I guess.
Yeah, you sort of echo what I said. We might underestimate the ability of artificial intelligence and autonomous systems. It is, however, the fact at this point that the expertise in AI is not sufficient to assure software and similar foundational electronic material in the same way that humans can. So I think that may change very soon. If we meet in a year, we may see that there has been significant progress, and we need to amend our conclusions for today. Our conclusions from this discussion. Thank you, everyone, for participating and for sharing your thoughts. Our conclusions for today is that AI is a tool in this area. It helps productivity. It doesn't solve all the problems. It cannot yet participate in the established processes, for instance, standardization. But looking into the future, there may be more that AI could do, or maybe not. Time will show. With that, with my thanks again to the panel, I pass it to our host for closing.
Thank you, Claire, and thank you to Adam, Mary, Fiona, and Ian. That's alphabetical order too, for this really great discussion. A lot of very good points on AI and software assurance. Apologies for the mistake earlier on. We have a session next week on security automation, and these words all begin with A. It's very confusing. There will be a recording and a report that will be made and circulated to you for further distribution. And I'd like to thank you again, and particularly to Claire for hosting this session with her usual je ne sais quoi. So with that, thank you very much, and look forward to meeting you all again in the future.